everyone, it's me again, and I am going to kind of walk through some examples from some of those prerequisite sections, and this video is going to tackle that section 6 of the prerequisite chapter on factoring. So I'm going to look at a couple examples of factoring and just kind of remind us of the things that we should be thinking through, the things that go through our heads as we do these problems. I'm going to start with one of the easier problems. And here we have what we call a trinomial. Trinomial means 3 terms. So 1, 2, 3. A term, again, is broken up with addition or subtraction. You'll see my next example a little further. There is still a trinomial, but it is a little bit more complicated. So again, we still only have 3 pieces, 3 terms, but they're just really ugly. Okay. And this problem here, when we have a leading coefficient, the number in front of our highest exponent is 1, they tend to be a little bit easier for us to come up with the factors. This is the result of FOIL. So if you can remember, multiplying 2 binomials together, we will come up with a trinomial. Usually our O and our I, those inners and outers, combine and give us that middle term. The first thing, though, with any factoring problem is to look at all of the pieces and see if there is something that we can factor out. So we always kind of want to take a little step back and look at the big picture before we start tackling it. So look back. This is a trinomial, leading coefficient of 1. Things in our brain says, okay, if I have a leading coefficient of 1, the method is to remember that the only way to get that x squared is if I multiply x and x. The next thing is we have to create this -3. So we're going to be looking for 2 numbers that multiply together to give me -3. But I also want to keep in mind that they have to add, so combine those O and that I, that oi, I should say, to create that -2. So 2 numbers that multiply to give you a -3. That add to give us a -2. Multiply to give me -3. And since -3 is prime, or 3 is prime, the only way we can do that is with a 3 and a 1. And now I want to make sure to get a -2. So to multiply to give me negative, that means 1 has to be positive, 1 has to be negative. And if they're going to add to give me the negative, I need that negative on the 3. So there we go. So x minus 3 and x plus 1. All right, moving on to this one, which looks, oh my goodness, a whole lot harder. But again, take a step back and look at the big picture. And that's when you start to become really good at mathematics, when you can kind of look at that and say, oh, well, that's just a quadratic where we have something squared. And notice this something is still there. So what I'm going to do is I'm going to rewrite this, and I'm going to do like a little u substitution. This little trick is something that shows up from time to time, and it's a lot of time to help that big picture look easier. So I'm going to let u be that ugly 5a plus 1. And then this turns into u squared minus 2u minus 3. Which is almost identical to what we had, except instead of x's, I have u's. So I can factor this, u minus 3 and u plus 1. But now we have to make sure to go back to our original problem. And we're going to replace that u back with the 5a. So this is going to be 5a plus 1 minus the 3. And 5a plus 1 plus my 1. Combining my like terms, 5a minus 2 and 5a plus 2. Okay, that is not the only way that we could have done that problem. We could have, and this is why I say always start and take a little step back and look at the big picture first. Because a lot of times students love to jump into things. So they see that thing squared. So the first instinct is to square that out, distribute the two, combine all my like terms, and so forth. And that would work great. In this problem, you could get down and it would still factor for you. It would be a difference of squares. A lot of stuff would cancel out, and you'd end up with 25a squared minus 4. But to get to that point, it would have required a lot of multiplying, a lot of adding, and a lot of combining of like terms. So we want to make sure always to kind of step back and give ourselves a break and say, okay, the big picture is, do I see something? Because a lot of times in these textbooks, they tend to want to show you things and not always just plug and grind it out. So just kind of be aware of that. Okay, here's another one. 6x squared plus 7x minus 5. Okay, we again, big picture. First thing I want to look at is all the three terms separate. Is there something I can take out? There is not. This is a trinomial x squared x kind of piece, one we've spent countless hours in courses before this, factoring them. So a lot of you are really good using trial and error. Some of you are not as good, and so a method that works is we take that 6 and that 5, or the negative 5 I should say, and we multiply them together. That gives me negative 30. So we take our leading coefficient and the constant term and we multiply them together. And now we want to find two numbers that multiply to get negative 30, but add to give us 7. So the middle term, that positive 7. Two numbers that multiply together to give us a negative 30, add together to give us 7. And we want a positive 7. Multiply to give a negative 30, add together, give us a positive 7. Sometimes it helps to list all the different ways to get 30. We have two of them here, reminding ourselves that we could switch signs around. Hopefully by pausing and waiting long enough, you guys see that a positive 10 and a negative 3 multiply together to give me the negative 30, add together to give me that 7. Okay, now what I'm going to do is I'm going to rewrite this equation with that 7 written in terms of 10 and the negative 3. So 6x squared, and I'm going to break this up into plus 10x minus 3x minus the 5. So I'm rewriting that 7 in terms of those two values. And now what I'm going to do is factor by grouping. Anytime I see 4 terms, into my head should pop factor by grouping. So out of these first two, I can pull a 2 and an x out. And when I do that, I'm left with 3x plus 5. Now for factor by grouping to work, I need this 3x plus 5 to show up again. And you can see it's almost there, but I need to pull out the negative 1. And I'm going to write the negative 1 just for emphasis. You could just write the negative there. Whatever is more convenient for you, whatever makes more sense. Now I have two terms. They're both pretty ugly, but they're still only two terms, things being divided with a subtraction. And both of them have this 3x plus 5 in there. So 3x plus 5. And if I pull that out, I'm left with my 2x and my minus 1. And I can always check factoring problems by refoiling it. And I should get back to where I got started. All right, let's move on to a few more. Hopefully these will go a little faster for us, I think. I have a couple more yet. This page should go pretty quickly. Here we have 2x to the 4th minus 8x squared. Again, back up, and first thing we should look at is there something we can pull out of everything, and there is. So I'm going to pull out that 2x squared, and I'm left with x squared minus 4. Now, some things that should happen when we see two terms. We should be thinking difference of squares, difference of cubes, sum of cubes. Because those are the things that we can have that have two terms that can go down further. This one happens to be a difference of squares. So it will factor x plus 2 and x minus 2. Okay. If you are rusty, please spend some more time working on these. Here we have 27x cubed minus 1. This one we're going to see, again, two terms. So we should be thinking difference of squares, difference of cubes, sum of cubes. This one happens to be the difference of cubes because 27 is 3 cubed. So this one will factor as 3x minus 1. Then we take this guy and square it. So we get 9x squared. We take the product of those two, but the opposite sign, so plus 3x, and then this guy squared. This piece usually does not factor. All right, another one on this page. X cubed plus x squared plus 4x plus 4. This has 4 terms. When I see 4 terms, bing, 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 my brain goes off and it's like factor by grouping, factor by grouping. So those are things that in our toolbox that should be happening. We could rearrange them if we wanted to, but I always try to do it just as it sits. So out of these first two, I can pull an x squared. And I am left with x plus 1. Out of these two, I can pull a 4. X plus 1. Now I see an x plus 1 in both of them. Oops, x plus 1. And I'm left with x squared plus 4. The sum of squares does not factor. Okay, until we hit chapter 3 or 4. Because then we'll introduce complex numbers. But right now, in the real world, x squared plus 4 does not factor. Okay, couple more. Just some weird ones. And the reason we do some of these is because there are applications that you will see in calculus that these sorts of things pop up. So we want to make sure to bring them to your attention. Okay, I'm going to look again, back up. And I'm going to look at these, and I see a 3 in there, but I also see all these half powers. So I don't like that. So I'm going to pull out the value that I can. I'm going to pull out this x to the negative 1/2. So I'm going to pull out that 3 with that x to the negative 1/2, because first of all, I don't like negative exponents. So we'll rewrite that after. But we're going to pull that out, which means I am going to subtract these things. So 1/2 minus a 1/2 is going to give me a whole. So here, my 3's gone. So if I subtract a negative, that's going to be actually adding a half onto this. So this would then be x to the 4/2. This would be minus 3x to the 2/2 and plus 2. Rewriting that. And here I'm going to actually write that as 3 over x to the 1/2. Here I'd have x squared minus 3x plus 2. I can factor this. And if you want to, you can leave that as x to the 1/2, or if you wanted to, rewrite it as the square root of x. This has a leading coefficient of 1. We need to get a positive 2, so we're looking two numbers that multiply together to give me a positive 2, but add to give me a negative. So that means I will have that x minus 2 and that x minus 1. Again, I went kind of quickly because we should be getting better at our factoring. Again, if you need more practice, please, 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 please do some more problems. Here is one more. Again, this will show up in something that we would see in calculus class, namely taking a derivative of a certain piece. And to be honest, when you are in calculus class, the calculus is not the part that's going to cause issues. It's going to be the algebra and the cleaning up or the simplifying of your final answers. So we'll have something like this after doing some calculus, but now we have to make that look nicer. The thing is to take out again that negative exponent because nice things happen. So I'm going to bring out that negative 2/3. What's left is this x, and then you'll notice it is at 2 plus x. Now if I pull out a negative, it's going to be subtracting, so that's kind of like adding. So 1/3 plus 2/3 is 3/3. Or simply 1. So the inside, I'm just going to work with the inside here, we have plus 2 plus x to the first power. These can combine, so I have 2x plus 2. Okay, and notice I can pull a 2 out as well. All right, so here I get this 2 times x plus 1. I'll kind of clean this back up here. So I'm going to put these little dashes saying, hey, that piece followed us down. It is to the negative exponent, so I'm going to put it in the bottom with the positive exponent. Okay, just to kind of remind us of some things as we're kind of still a little rusty, not that I would have to do this, reminding ourselves what 2/3 power means. It is the cube root of something squared. Okay, the bottom fraction tells us the root, the top one tells us the exponent. Hopefully this helped bring up some of those factoring things, also threw some of these uglier ones at you. I'm hoping that they bring back some thoughts of how you factor. If not, if you need more practice, again, there's some in the textbook. There also is that extra video under the resources in our web assignment. So I'll see you in the next video.